Hi everybody, welcome to video number 38. In the past videos, we've been working on some digital topography from Mount Shasta. Most recently, we reprojected that data, so it's now in a UTM coordinate system. So now I want to start visualizing the data of Mount Shasta. And the best way to do this is by making a hillshade image. So in this video, I'm going to talk briefly about what a hillshade is, and then show you how to make one in ArcMap. So a hillshade, or shaded relief image, is a visualization of the digital elevation data. And the way this is generated is that the computer simulates shining a light on the digital topography. And so in this case, if the light is shining from 315 degrees or out of the northwest, you can see that the computer has simulated brighter, better illuminated areas versus shadowed areas. In this image, there's a pretty flat surface with a road going across it, and then we've got the edge of a plateau here with some of these rivers that are dissecting headward and have created some very steep slopes up against this plateau. And so those are obviously showing up in the shadow. So digitally, what's going on is that the computer's simulating the light, and it's estimating the brightness with which that surface would be illuminated. And it's assigning a value, or a digital number, from 0 to 255. If that pixel is completely in the shadow, it will get a value of 0. If it is directly facing the sunlight and it's very bright, it will get a value of 255. And so then when we display those digital numbers as a grayscale, as we've done here, it actually appears to be topography, even though, again, it's just a raster of numbers from 0 to 255, where each one represents the brightness or shadow of that pixel. Now, importantly, we can specify not only the direction of the sun angle, so anything from 0 to 360, but we can also specify the sun angle. In other words, this value h, whether you'd like to illuminate your scene from a very low angle, like 20 degrees, or have the sun directly overhead at 90 degrees. And that's going to affect the type of result you get. If you have very subtle topography, you might want to use a really low angle. If you have really intense relief and intense topography, like the Himalaya, you might want to use a higher sun angle. Otherwise, everything will end up in the shadows. Okay, so that's or I should say that the most common way to finish off a hillshade is to display it beneath a digital elevation model, and to assign a color scheme to the digital elevation model so that colors are scaled according to their elevation. In this case, green is low, white is high. Then we make that partially transparent, in this case 60% transparent, and we get the benefits of both seeing the colored elevation and seeing the hillshade beneath. It can make for some really powerful visualizations. In this shaded relief image, what we're seeing is actually a fault line along the Alpine Fault in New Zealand. Okay, with that introduction, let's go ahead and make our own shaded relief image. So I've got our digital elevation model open in ArcMap. It's projected in UTM coordinates. And to make a hillshade, we'll go to Spatial Analyst, Surface, and then hillshade. And the inputs are quite easy. Choose our raster. I'll specify a file name. In this case, I included the word hillshade at the end to remind myself what it is. Then you set the azimuth of the sun, the direction it's shining from. Then you specify the sun angle, how steep in the sky it is. And finally, this Z factor is very important. The hillshade calculation assumes that the vertical units of your digital topography are the same as your horizontal units. So in other words, if your elevation's in meters, it assumes that your horizontal coordinate system is also in meters. In this case, we're lucky. We're in a UTM projection, so our spatial is in meters, and our elevation values are also in meters. So we're able to keep a Z factor of 1. However, if our image was still back in an unprojected angular coordinate system of latitude and longitude, we'd need to use a Z factor of something like 0.005. And I'll let you read up more on the z-factor, but it's really important to get it right. And there's a lot of info about it right here in the side panel. Okay, so we're going to leave that at 1. Everything's set, hit OK, and we'll wait for our hillshade to pop up. Okay, so here's our hillshade. Ta-da! We can finally see that we're actually looking at a volcano. And I'm not sure what these striped lines are. Those may be an artifact of having reprojected the data. I don't think those would show up if we hadn't reprojected the data. In any event, this is good enough for the example case. Now I just want to show you how to display it with the elevation over it. So I'm going to move the elevation file to the top. Then I'm going to right-click Properties, Display. I'm going to set to 60% transparent. Symbology, I'm going to set to my favorite elevation scaling scheme. Okay, so now we've got this nice hillshade displayed and colored. Look at some of the wonderful things we can see. Right here, big rhyolitic lava flow. If we zoom in on that closely, we can see some wonderful detail. See some of these ropey textures of the flow, and we can see the flow spilling out and stopping. That's really nice. Likewise, if we go over to this river valley, zoom in here, we can see some pretty amazing detail inside this river valley, a road coming down the hillside. We can see an inner canyon and some terraces. So we can see some beautiful detail. Here's another lava flow. I think that this is a LiDAR-derived image, so I think we're able to see some wonderful detail for that reason. There's also some smaller volcanic cones that are developing out in the periphery of Mount Shasta. So spend some time looking at this, enjoy looking at the volcanic structure, and in summary, you have now learned what a hillshade image is and how to generate a hillshade image in ArcMap. In the next video, I'll show you how to generate some contours. Thanks for listening.